Yes, we are live now. Please start.
Okay, thank you, sir. A very good evening, everyone. This is Madhuganga, your moderator for today's industry expert session. In today's session, we are going to understand the role of AI in industrial automation. To help us out with this, we have Mr. Bhaskar Sinha sir with us. He's currently leading the innovation team at Schneider Electric with a focus on disruptive technologies and solutions to solve current and future customer problems. Besides that, Sir has 23 plus years of experience in engineering software and industrial automation industry. His previous roles include work in R&D, product management, marketing, and sales. Sir has developed and launched 10 plus commercially successful software products as well. We are really excited to have you with us, sir. Thanks a lot from the whole IIT degree team. And without further ado, I would like to request you to begin today's session. Over to you, sir. Thank you.
Thank you, Madhuganda, and thank you, IIT, for providing me with this opportunity to share some of my thoughts and experiences that I've gathered over a short period in this industry. So let's start off. So I will cover primarily, how we at Schneider are using AI and where we see opportunities, how we see this world changing over the coming years. A quick background into what Schneider is. I'll not take much time. We are here to empower all to make the most of the energy and the resources. And primarily, Schneider is driving the sustainability both within the company and for our customers. And we are leaders in the space of sustainability. Overall, if you look at the company, it consists of two major business divisions. One is the industrial automation. So I belong to the industrial automation. And then we have the energy management business. As you can see, the larger part of Schneider is dealing with energy management solutions. And then we are now integrating the solutions from the industrial automation and the energy management together to bring in better efficiency for our customers. This quickly talks of the various products that Schneider has. It's showing only a limited view. Our focus has been to develop connected products, but as you know, that for developing any kind of automation, any kind of AI kind of solutions, first thing you need is data, and you need the context where you are able to connect between different devices, systems, and you are able to aggregate all the data and get it to process the data and understand the meaning of the data. So our focus is on the connected products, and then we service various verticals such as buildings, data centers, industry, which is a large area, and then the infrastructure. So here are some of the names of the customers that we are serving within India itself. As a mission for Schneider, as I said, it's primarily sustainability and efficiency. Here are some of the technology partners that we work with. You can see the top technology players that we need to work with and collaborate because we cannot do everything on our own. Now, coming back to today's topic on AI, as we see, AI today is what some centuries ago was electricity. So which means that when electricity was discovered, it kind of unlocked huge potential. So many applications got developed which used electricity. Today, AI is in such a state where the technology has developed. Now it's up to us to develop various kind of applications in almost every segment so that we are able to unlock the true value of the AI. So this is a very, very exciting time for anyone working in the area of technology, particularly AI machine learning. A quick background on industrial automation, what industrial automation is. So primarily it's the technique of making a apparatus, equipment, or system that could be operated automatically, right? So that's the basic definition. And then you have process automation and manufacturing automation, or the discrete automation. Process automation meaning like you have the refineries and so on, where you cannot stop the process once you start it, it has to continue all the time. And then you have the batch where you produce units. For example, you produce units of cars and so on. So these are the different areas of the industrial automation. Again, if we look at AI, what all benefits AI is providing? Sustainability is one of the key areas. Efficiency is also linked with sustainability, where you can drive much more efficiency into the system. Customer satisfaction is very, very important, which means that we are trying to make sure that customers are able to do more and within a shorter period of time, within less cost, with better quality, with better safety, and so on. And workforce enablement means that how we can support the workforce, the engineers, to do their job better. So AI kind of helps such engineers, which will be able to make an engineer do his job better, or other people working on the factory floor do their jobs better. If you look at primarily the manufacturing side, how AI is improving manufacturing, here are some of the areas that we are working on. For example, it's helping you to forecast, the demand forecast, the supply forecast, and so on. Predictive maintenance is a big area where you try to see that based on the conditions of your equipments, your assets, are you in a stage where you will be able to meet your demand? Will there be a breakdown in between? And how can you readjust your load such that you don't face a situation where you're not able to produce because of the breakdown, or you're consuming a lot of energy, or it's life threatening for the people who are operating them. Hyper personalized manufacturing, meaning that depending on the person and the job that they're doing, how you are able to improve the efficiency, and how you are able to make the job easier for the person to do, so that they are able to do the job in a much better way. Automated material procurement is another big area where you automate the process based on what you're producing or what you would produce in the near future. You understand exactly what kind of raw materials or resources are needed, and you kind of automate that process of procurement. Efficiency increasing is key, and quality control is again very, very important, that whatever we produce, it has to meet the safety standards, it has to meet the specifications of that particular product, and so on. A quick view of the four waves of AI, and they are kind of running in parallel. The first wave that we see is called the Internet AI. This started flourishing around 2012, and all of you have been using it. Right now, we are using it. For example, YouTube, Amazon Shopping, or Google, and so on. So you know that it's primarily centered around the recommendation engine. You watch one video, it suggests more videos, and so on. You buy one product, it suggests more products based on what you're searching. You start seeing the advertisements around those searches, and so on, right? So that's the first wave of the Internet AI. The second wave is basically the business AI, which is, again, we all are kind of using them. The moment you swipe your credit card, it undergoes a lot of checks to see is this a valid transactions, and so on. And then there are other applications like giving a judgment, right, based on the information and the documents, and so on. Medical diagnosis based on the input data and condition of the patient, predict what would be the probable cause of the inconvenience to the patient, and what would be the suggested medicines, and so on. Then the third wave of AI, which is also happening right now, is basically the perception AI, meaning now you add the sensory organs to your AI, like vision has been there for quite some time, the cameras, right? I mean, where you capture the information, you process it, and then you take appropriate action around it. Similarly, we have voice. There are so many applications where we use the voice in our day-to-day interactions or life. And finally, the fourth one is the autonomous AI. We are also seeing that today. autonomous car is one of them, but there's tons of automation happening everywhere, including in our Schneider factories. You can easily go and see the kind of the self-driving car, that is available. There are some great information and videos where you can see how some of the companies like John Deere and so on, they're doing the automated harvesting, where the tractor is like a self-driving tractor which goes on the field, understands if the crop is ready, and it kind of takes the crop and sends it for processing and so on. Amazon warehouse is another great example of how the throughput has been increased in shipping all these material, packing and shipping all these materials and so on. So these are the four waves that we see right now happening in parallel today. Now, let me give some examples in our domain, in our industrial automation domain, that's happening right now. And one of the important requirements that we see from our customers is the need for autonomous operation and remote monitoring. So what does autonomous operation mean and why this is required today? So autonomous operation means that you have a plant, let's say it could be producing water, it could be producing some other chemicals or some other products in that plant, but it's in a remote location. There are challenges that we see coming from different countries where you do not have people available in those remote locations. The skilled labor, they are not available in those remote locations to run those plants. So can you run those plants in an automated fashion where you don't need people to sit and run the production or run the process in those plants? And then you can have 5, 6, 10, 15 of those different plants in different locations running with a remote monitoring center, which could be in a city where you easily get people, skilled people to monitor these various plants. Now, the objective is you're not sitting remotely and operating the plant. The plants are operating autonomously based on the conditions that you have set in terms of your throughput that you want, what products you want to produce, what's the energy efficiency you want. You take care of the sustainability, parameters, the quality parameters, and of course, you limit from a safety perspective. Once you have said that, it's operating on its own. And your job is to see if there's a forecasted demand and you want to switch from one product to the next. That's where you will go and tinker and change the recipe of what that particular plant is producing. The other thing you're looking at is, for example, predictive maintenance. Are there any issues that are happening as you are remotely monitoring these plants, which could actually lead to a shutdown or could lead to safety situations and so on? And what kind of actions you can take to make sure that you don't end up in a situation which leads to shutdown of the plants or it creates unsafe conditions. As an example, let's say as an operator, I'm sitting remotely and I see on my dashboard that, hey, here's something where the energy is coming from a windmill, and there's some trigger which comes on my dashboard saying that there's some problem with the windmill, right? You can actually have the drones flown in there, which can go up and see and look at the blades and understand the conditions and interpret that here's a problem and this could be the consequence of that, right? And these things are already happening. There are proof of concepts that has been demonstrated, and there are applications which are running. The other example is you can fly the drones if you see that there's some safety issues or some leakages happening in, let's say, a refinery processing plant or so on. You can fly the drone, which can detect if there are any leakages, or you can have the robots which can walk down and see what's the problem. Maybe it can go and do some maintenance activity which you're controlling remotely. For example, a common problem is if your instruments and your systems are running on battery, they are low on battery, or the battery has drained down. So you can send these robots to go and replace the batteries, as an example. So all these things are happening today. What's important here to understand is when we look at AI. It means that, there are a couple of layers where you try to look at processing the information, and then you need to take some actions based on the information that is being processed. Now, this information processing happens at different layers. For example, there is certain information which needs to be processed at the field level itself. So it has to quickly notice the situation and take an action. A clear example is a self-driving car, where you need to have your logic of looking at the road conditions, looking at the different environment, and take the appropriate decision of how you should speed up, how you should steer, and so on. You cannot rely on a system where it will take the data, observe it, push it to the cloud, it does the processing and sends back the results. What if the connection breaks and all that, right? So there are some critical applications which you have to run at that layer. It has to sense, process the information, and take the action. And then the rest of the information can be sent to the cloud, where it's able to take get an idea, for example, how many vehicles on the road, what's the road condition, and so on, which can be processed on the cloud level. And then you take decisions which path the vehicle should take, which will help you to reach to your destination faster, and so on. So AI will be running at different layers. It will be running into individual components as well as big enterprise systems as well. What we need to take care is, number one, we have to ensure that there's the data privacy, data security issues, okay, which needs to be taken care. Reliability is key, safety is key. The other things or the challenges that we face in our industry is something termed as explainable AI, where a decision taken by a AI system, the user has to understand why that decision was taken rather than treating it more like a black box and so on. So here's one example. We have more examples. For example, if you're building a plant, it could be a refinery plant, it could be a manufacturing plant for the automotive and so on. The idea is that how you can build a plant as soon as possible so that you can produce whatever you're supposed to produce through that plant. We use a lot of AI in this space to shorten the period from the design, build, commission, okay, during this process so that you can do things faster. Here, what we do is we look at knowledge capture, where we encapsulate the previous knowledge of the engineering team who have designed such projects in the past and commissioned them. And then we reuse that knowledge for a new upcoming plant or new system that is coming up. Of course, there's supervision always available by the experts to see that whatever results are there, they are accurate and correct and so on. So this helps us to get the plant up and running faster. Here's an example, another example. It's the Esp pumps. These are the pumps which go and drill the oil from the ground, right? The crude from the ground. And the application that we built here is it looks at the quality of the crude by looking at different sensor values and also the health of this particular pump, and tries to ensure that how do you kind of adjust your parameters so that this particular system doesn't shut down, because these are in remote locations. So you don't have people nearby to really man them and all that. So if they break down, you will need the technician to go there. It may take some time to reach there and fix it and so on, which leads to a production loss. So again, how do you run this system in a way which helps to ensure that it doesn't fail and it has extended life and it meets the throughput criteria. Another example, pump energy consumption monitoring. For example, pumps, they consume a lot of energy. And from a sustainability perspective, from efficiency perspective, you want to make sure that pumps are running in a way which consumes the optimal energy. So how do you kind of, again, use AI to run these pumps, understanding the entire systems in a way which not only is efficient, but also extends the life of the different assets, maintaining the safety aspect as well. So what are the skills required for AI, right? I mean, on the left side, if you see curiosity, confidence, and perseverance, these are more like behavioral traits. And the other piece, which is very, very important, apart from knowing the different algorithms and the maths and the data science piece, it's extremely important to understand the domain knowledge, because without that, it's garbage in, garbage out. It's important to understand the business, okay? What problem we are trying to solve. And then particularly in applications where you are trying to build something which will run on its own or provide more value, it is very, very important to be a good software engineer or know the software engineering skills, because it's not just enough to give some charts to the end users. The charts are useless because you don't want the end users to become data scientists to interpret those charts. You really want to solve the problem. And hence the software skills are important. So when I go and hire AI engineers or machine learning engineers, I ask them one question: do you love your job? And if I see that they say yes, I love it, I know that they have really not worked in the field. One of the biggest problem with or the challenges with AI is the data. You have to deal with lots and lots of data. There are a lot of challenges with the data, and I'll come to that in the next slide. And you have to really love processing these data and analyzing these data and all that. It's quite frustrating, to be very honest, right? And then making meaning of the data. And then you have to also understand what the end user is looking for. I'll give you an example. As a data scientist, we see that what kind of algorithms we should be using for the end users, and you pick a particular algorithm, and then you ask the end user that, okay, if you want to use my application, here are the 5 things that you need to do to run my application and get some beautiful charts. The end users say, I'm not going to use it because it's quite cumbersome. For example, you need that the end user should do some kind of labeling, which is a very, very common problem. The domain experts or the end users, they would do some labeling and tell that, hey, this pattern means that such event has happened, and the end user has to mark it within the specific box. Could be 4 hours or within the 10 hours accurately, and say, here's what the data means, the labeling part. Instead of that, you have to write those software or algorithms which could automatically adjust the boundaries and all, because human will be the inaccuracies will be there, because we cannot be precisely creating such boundaries and use the cursor and the mouse to select that and then label that. So there will be errors. So we have to build such algorithms or softwares which could take care of the human limitations, make it easy for them, but you process that particular algorithms, okay, and feed it to your machine learning algorithms and so on. So these are some of the important things which are very, very important. What are the top challenges of AI? The number one challenge is availability of data. We have seen that for most of the applications, the data is not available. And what are the reasons for the unavailability of the data? Number one, you have these measurements or sensors, okay, for the industrial application. Either they are not working, they are not calibrated, so they are giving wrong values, or you need different new kind of sensing, which is not available. So you need to put a different kind of sensors, right? So accuracy consistency is a big, big problem here. Data security is another big problem, which is a very big issue in terms of, particularly in industrial automation. Safety is very, very important. You have to ensure that the security aspect is not being compromised. Computing power has been increasing every day, but it's always a limiting factor when you look at computing power, and particularly if you're trying to run your applications on the edge instead of, let's say, on the cloud. Connecting back to the controls, which means that it's not just enough that you sense that here are the measurements and then you interpret that here are, let's say, the problems or inferences. You would also like to connect it back and make it autonomous. As an example, if, let's say, you're driving a semi-autonomous car and the car tells you every moment, move the steering 1 degree to the left, move the steering half degree to the right, and it tells you every millisecond, right? It's humanly impossible to take those instructions, right? Because we cannot move so fast. So it's important that you integrate it and close the loop, but the system itself will do the movement. So that's the closed loop control part. Defining copyright and fair use is again very, very important. Ethical AI is another very, very big area which is being debated. Availability of talent is always a problem, and the industry is going to need more and more people for this particular skill sets. Now, here's a quick view of what are some of the jobs that can get impacted because of AI, and what are some of the new areas which can enhance. I see that there'll be more jobs created, but just that it'll shift from one area to the other. So in this graph, again, you can read this book, wonderful book, AI Superpowers by Kai Fu Lee. If you see things which are repetitive in nature, which doesn't lack, which is not creative, it's more monotonous, or it's the same thing you are repeating, and something which doesn't require human interaction, those are the kind of the jobs, that's the danger zone, right? Which will definitely get automated by AI, and they are getting automated. But on the other hand, you will see that AI can play different roles depending on the conditions of whether it needs creativity with social, or creativity with asocial, means not much of human interactions and all. How AI can play a different role for each of the segments. This is another depiction of things which requires high dexterity. Your environment is highly unstructured, meaning that you really cannot just take the data and push it into your computing device. There's a lot of interpretation, understanding is there. It's always new. And wherever human is required, human interaction is required, definitely, those kind of jobs will continue to remain, and AI will make them even better and make them flourish. So key takeaways. Number one, of course, the skills that I mentioned. Okay, you need to love data. You need to understand the data. You need to process, know how to process them, and so on. The other thing which is very, very important is don't just try to use the same hammer to push the nail, right? I mean, there are so many algorithms. We need to understand the algorithms. Okay, so there are a lot of jobs which requires you to design new algorithms, but then there are many applications which are built using the existing algorithms, but you need to know the intricacies of those algorithms. What are the limitations of those algorithms? What are the ways to use those algorithms, and use the appropriate one based on the different conditions which are written below. So pre-processing is very, very important, and you can do the right pre-processing only once you understand the algorithm and you select the right algorithm. And another thing is post-processing. So anyone working on AI machine learning knows that pre-processing and post-processing is where you spend maximum time cleaning up the data, and normalizing the data, and so on, right? And then, understanding the business context, why you are using it, what problem you are trying to solve for the end user application is very, very important. Domain knowledge is another important area. So either you can acquire domain knowledge, in certain cases, you can have someone sitting with you who kind of collaborates, and you are able to understand what that application means, right? Insights of those application. It could be financial domain, it could be industrial domain, or any other domain. Software and hardware engineering is again another very, very important area, because end of the day, producing charts for many of these applications is not enough, at least in the industrial automation space. You need to actually engineer them. So either you will engineer it through the software, or you have to implement it on the hardware. Sometimes on small devices with small, very little memory footprint, you have to deploy your applications. You have to then upgrade your applications. You have to continuously provide support to the customers. It has to have that ability to adapt itself, because you can't say that I've built one model and it will last forever. It doesn't work. Models become obsolete very soon, as it is operating. So it has to have that capability where you are upgrading the model. Either the model is upgrading on its own if you have engineered it well, or you are pushing in those models, new models from time to time to make sure that they are relevant. And finally, I believe that AI is going to create a lot of demand. It's just that it'll create new kinds of jobs for this industry. So with that, this is what I had to share for you all today. So I'm open to questions that you have.
Yes, sir. Thank you so much for the very insightful session, sir. We have few questions in the chat box, so I'll begin with the first one. So it is domain related actually. I'm an instrumentation engineer working in oil and gas design engineering sector. What
Mhm.
can I do to gain entry in the industrial AI sector, if possible, at Schneider?
Okay. We are actually working a lot on smart instrumentations, okay? Because that's the entry point, right? Measurements are the entry point for any AI. So definitely, you can go to Schneider's corporate website on careers. You can see the job listings. You can go to LinkedIn postings. You can see the job listings. So you can start applying from there. You can connect with your coordinator, and they can connect with Schneider's coordinator, and they can get you in touch with the right kind of postings. But definitely, we have lots of opportunities in the area of AI machine learning. Instrumentation is the key. Without measurement, you can't do anything.
So are there roles for freshers also, or should have some experience to get in?
Definitely. I mean, as long as the person has the ability to learn things quickly. Okay, so it definitely we are looking at people at all levels, both from freshers to the experienced people.
Thank you so much, sir. Moving on to the next question. How AI can be used in telecom sector?
Yeah, I'm not much familiar with the telecom sector, but definitely, there's so much of networking happening, right? I mean, so much of data flowing. How do you make sure that the throughput of the calls is there? The network doesn't get choked. Your call quality is up and running with the given infrastructure. There's lots of opportunity in there.
Yes, sir, sure. When data is inaccurate from sensor or insufficient, what are general techniques followed here to augment the training set for better performance metrics?
Yeah, great question. So this is a very, very common problem. There are a couple of things. Number one, you develop an anomaly detection engine as a first step, right? Which tells you that the sensor is not behaving right, and you look at the surrounding data and so on. That's one of the common techniques. The second one is where you develop soft sensing, which means that based on one sensor and the surrounding sensors, you kind of create a virtual twin or digital twin of that. And you know when they are deviating because there's always a correlation between different measured values, right? So you see something is deviating, then you actually let the digital take over and you raise a maintenance alert that the sensor is not working, it needs attention until it gets fixed. You have the digital sending the value to your system, right? And of course, a lot of the sensors today, they come with inbuilt capability, which alerts that there's a problem. As an industry, we don't process that data today because of various issues. I think we need to process that data from those sensors. They have a lot of information. So we need to pull that information and we know that the sensor has an issue.
The next question is also related to domain knowledge. How to build domain knowledge, especially for someone who has already taken electronics and communication? Should they go for MTech or get exposed to industry, which is preferable?
The best way is that you can learn anything. Okay, I can tell you. You need not be expert in that domain, but you should have access to someone who is having that expertise. So typically, the way we do is we work with consultants, we work with university professors, right? Uh, people who have already worked, and internally, we have domain experts. So we work with them. It's impossible to learn or get information on all domains. It takes 20, 30 years to become an expert in one of the domains, but you should have access to it. And I can tell you within 2 to 3 months, you get enough information to know the basics of that domain. And then with this combination, okay, you are able to fill the gap of the domain side.
The next question is, I am a mechanical engineer looking after maintenance work. Sir, is this possible to share some concrete examples of predictive maintenance using AI? Because equipment reliability is our key concern.
Yeah. So actually, there are many, many examples. I mean, let's take the pump, right? There's always a vibration sensor attached to the critical pumps. Okay. Uh, there are different mechanical failures that happen with the pumps if either they are overloaded or not used in the right way or because of aging and so many factors, right? So that's one way where based on the current condition of the pump, right, the way it is behaving, the vibration is one of the key measurements, the electricity it is consuming, the energy that it's consuming based on the throughput, right? If there's a deviation and all that, you can detect that there's an issue with the pump, and you can exactly know what kind of issue is there. Is there a bearing issue, or there's some breakage happening, or some nuts and bolts are loose, or there are different 15, 16 different kinds of issues could be there. So you can predict them. Now, what's happening today is that if you do not have this predictive capability, you cannot automate, because the automation will tell the pump that, hey, change the throughput. Sometimes it will say lower the throughput, or it will say increase the throughput of the pump. But if its condition is not right, the pump may fail and your entire plant can be under shutdown, or it can create safety issues, right? So these predictive engines are very, very important to drive the autonomous behavior or the automation in these kind of plants. So again, you see that how do you develop such AI models and engines? You need to know the mechanical aspects. And if you know those mechanical aspects, then it becomes easy with the domain to develop these AI models by working on some of these real life plants with these kind of pumps, taking the measurements, understanding the faults, and then building it into your system.
Thank you, sir. The next question, what is the difference between domain and business?
Okay, domain means, for example, you're in a chemical plant, so you should know the chemical equations that it's undergoing, right? The transformation of material from one form to the other at different stages, right? So that's on the domain side. So you understand the process, right? That's the domain side. Business means that what is it that the customer is seeking? They're looking at improving their revenue, their throughput, or they're looking at improving their profit, or they're looking at sustainability, becoming more greener, or they're looking at safety aspects. Typically, it's a combination of these different things. So you have to understand that, right? Because based on that, you are going to design and devise your algorithms and your solutions, right? So that's on the business side.
To learn AI, should we have any prerequisites knowledge of data science field? I mean, how can we progress if we have to learn AI from scratch? Any resources you may suggest?
I think I've been tracking AI over the last 10 years or so, but when I joined in Schneider in 2016, we always started with Andrew NG course, most of our people from Coursera, right? Fundamental course that we started. And then we started writing our own algorithms, okay? 2016, we were writing our algorithms. They would take ages to converge on our laptops, right? 2018, we saw that there are tons of algorithms which are easily available, which you just need to download and just keep running. Today, it has become so easy to get access to these different algorithms. There's so much of knowledge. Most of the things have been made free and easily available. It's really, really easy to pick up, I would say, on the AI side, as long as you know the fundamentals. you can go and understand under the hood what the algorithms are doing. As I said, you should know the domain, you should understand the data, you should know the business. And if you do that, and you know a good amount of software engineering skills, end of the day, you have to deliver something, not just deliver the charts. You will become good at it. Okay, you have to just invest more time reading, accessing the course that IIT is doing, right? I mean, this online BS course is a fantastic course. One of our team members is undergoing it, even though he's himself a AI machine learning practitioner and expert in that area. He's undergoing it so that he can learn the maths that's going behind it, and he has gained a lot, right? So you can take these courses which are available, which can help you to become better at your job.
Yes, so we do have AI course when we reach to degree level by Professor Deepak Khamani from IIT Madras only. So yes, you can check out that as well. The next question is to implement any AI model into any of your business problems, what plays a major role? Interpretability of the model or how well it performs on the desired evaluation metrics?
Sure. So of course, after you have gone through the hurdle of getting the data, right, access to the data, that's always a challenge. For our industry, it's not very easy to get access to the data. Your next challenge is to really understand what are the key features, right, in that data. And for that, you need to understand the business, right? I mean, that application, what it is doing. What does that data mean, right? I mean, that takes a lot of time. Okay, once you have cleaned the data and processed the data, you need to understand the data, and for that you need to know the application. This ESP pump, right, electrical submersible pump that I was explaining, team has to understand what was that process. Okay, they were drilling oil. Okay, what was the problem? That oil gets mixed with some mud and dirt and stones and all that, right? That goes and hits the pump, and there are some bubbles getting created which kind of stalls the pump and it stops working. So they have to understand all that, and they have to correlate that with the data, right? So first thing you have to do is to do the data analytics. For that, you have to understand the application domain and all that, sit with people and get it. So once you have done that, your next challenge is always around accuracy, right? Which is the best model, and how do you kind of pre-process the data and post-process the data, okay, to get the desired accuracy. And a lot of struggle goes then in trying to figure out the right model, the right data transformation that you need to do, and so on. And then will it fit into your end application? Do you have that compute resources? Do you have that access to upgrade your model and so on, right? So these things then come into the picture. So I would say that, these are some of the hurdles or challenges that people go through. And then the classic problem of over-reporting, under-reporting, or false positive and false negative, right? I mean, one of the things that customers constantly ask is that if you say this is a decision, right? Whether it could be any decision, they don't want that, you just tell me that I'm 90% confident or 95% confident, because they are saying that you have to be confident or not confident. Because if you tell them I am 90% confident, he has to go and check the entire work. Okay. So he says it's of no use, because I have to sit down and see that if AI has missed, which is that 10% that the AI is saying it's not confident, right? So another challenge is where if you're right, you have to be right. If you're wrong, you should know which portion is wrong. Okay. And then you can ask the user to come in and work on the area which is wrong, rather than asking him to go and look at every area and figure out which is that incorrect area. So these are like the common challenges which we face every day. Computation time is another thing, particularly if you're building application, not during the training phase, but if you deploy it, the user is not going to sit there and wait for your model to give the answer, right? They want things done faster, right? So how you build models which will give you the results faster, accurate, and so on.
So the last question here is, can we predict what a person will do by providing his data to AI model? Or can we know what is a good field for someone to study, or what work they should do based on the behavior of the person?
I think that that's a behavioral question, so it's
Yes.
quite tough.
It's
So as I mentioned, some of the skills that are required here, right? Curiosity, confidence, and perseverance. So the question is that how much curiosity is there with the person? Confidence is required because you will feel, failure happens every day when you are working on these kind of AI work, and perseverance, like don't give up. Okay, that's what we do. So it's the degree of these left side, that thing you have, right? That will determine that.
true, sir.
So
Uh,
my one thing is that if you are really working on serious applications on AI and you think it's uh, it's an exciting thing, it is exciting, but there's a lot of pains involved in it. So you should embrace the pain and make that exciting. So that's my message.
the answer to this question, I guess, will be the combination of AI and behavioral science, which will lead to maybe a possible answer.
Yeah.
Uh, the last question here is like, is it possible to visit any of the Schneider plants in India and get knowledge of the implementation or the learnings?
Yep, sure. I mean, I'm sure that, as a industry visit that could be arranged. We do have such industry visits. We have some of the smart plants located in India itself. Some of them could be seen remotely. Okay. You can do a factory walk sitting remotely, and you can actually visit the factory. But of course, you have to take a lot of permissions because there's a safety issue, and all those things are involved into making a physical visit. But I think from IIT side, you can arrange for such kind of visits to one of the Schneider plants.
Thank you, sir. Okay, one more question came up. As in today's world, most of the algorithms are readily available. Can you give an example of an instance where fundamental knowledge of linear algebra starts helped in solving the implementation of the problem?
As I said, explainable AI, or if you're trying to solve something blindly, if you just say that, hey, I'll use deep neural network, okay, for a simple decision tree or something, right? I mean, it doesn't work, okay? You need to understand the problem. You need to see that what's the math behind which is best suited to solve this problem. Sometimes simple linear algebra is enough. Sometimes you have a discontinuity. That is where you will use the decision trees, okay, which consists of combination of linear spaces and so on. So you need to understand that by your initial data analysis, right? So these are some of the common things. We see some of the people simply use neural network because it works, okay? But you just can't explain the results. So it's better you get down with your pen and paper and do the basic math and see that most of the times you can solve many of the problems using simple linear algebra or using a simple algorithms which are more white box, which are more explainable.
Sure, sir. Thank you so much, sir, for answering all our queries so patiently and for today's presentation. I think that will be all for today. Again, thanks from all the IIT India's degree. We had a wonderful session. Any answer?
Thank you, and it was my pleasure to be here. If you have any questions, feel free to reach out. I'll try to provide to the best of my knowledge any information that I could provide. But definitely we have a great team. They could provide much more information that I can provide because they are working on the problems day to day, hands-on. So again, thank you for providing this opportunity. It's honored to come here and interact with all of you here.
Thank you so much, sir. Thank you so much.
Thank you. Have a good day. Bye.
Yes, sir.